Today, we're going to look at solving equations graphically, algebraically, and numerically. Our first focus is that we can solve equations graphically, so you're going to need your graphing calculator with you. What you want to do here is you want to plug your equation into y equals on your calculator, and if you're solving for x, you want to look for the x-intercepts. This means that you're going to have a solution in the form of x-intercept 0, or in other words, you're going to have some number 0. So we're replacing y with 0. When you solve graphically, you will be required to do a couple of things. You're going to need to draw a picture or a sketch of what your curve looks like. Okay, you're also going to need to tell me what your window size is, and we'll look at how you set a window, standard window being -10 to 10 for the x's and -10 to 10 for the y's. The last thing you're going to need to do is tell me what your solution is. X equals what and y equals what. So, getting started here with our first equation. Let's plug this equation into y equals. So when we turn the calculator on, we go to y equals, we'll clear out anything that's in there. We're going to type in 3x minus 12. Okay, then we can hit graph. Now, looks like my window's already set to be -10 to 10 and -10 to 10. If yours does not look like this, you're going to want to adjust the window. The window key is right here, and you can notice on mine that the x minimum is -10, the x max is +10. The y min is -10, and the y max is +10. So going back to the graph, then, this is what you should get. Our job is to look for the solution. The solution is the place where we cross the x-axis, our x-intercept. This is our solution. So we can look at it and we can guess that our solution is around 4. I want to show you right now how you can find that on the calculator. What you do is you hit second trace. That will give you the calculate menu. So second trace, we're in the calculate menu. We're going to try to calculate the 0. We're going to find the 0. So we move down to number 2 and hit enter. Now, it's showing you at the top of the screen that this is the equation that you're on, or the graph that you're on. It's saying, are you on the left side of your 0? So what I need to do is find my cursor. There it is. And since my 0 is here, I need to stay to the left side of it. So I'm just going to hit enter here. You'll notice that a little arrow pops up. Then it asks, are you on the right boundary of your 0? So we must cross over our 0 and go past our 0 to the right. Then we're going to hit enter again. Another arrow pops up. The screen right now says guess. We aren't going to guess at what our 0 is. We're just going to bypass that by hitting enter. It tells me that my 0 is at 4. So my solution is 4, 0. So I'm going to write in here, x equals 4 when y equals 0. To the right of this, I'm going to write what my window is. And if you don't remember, you can come back here. The window is -10 to 10. This is my inclusive x-axis. And then -10 to 10, my y-axis. So the last thing I need to do is to draw a picture of the graph that I have. So it looks like everything is centered. And my graph looks like it's coming in right about down here. I'm not on my y-intercept. I'm crossing at about 4. Okay, and then we're going to draw the line that we see in our calculator. And that's how you want to go about looking at this. So once again, things you're going to want to watch for. You might need to reset your window. Standard window is -10, 10, and then -10, 10. When you're trying, let me just move this out of the way right now. When you're trying to find that point right there, that x-intercept, you want to do second trace. Okay, you're looking for the 0, and then you have to be on the left side, you have to be on the right side, and then you have to hit enter. Okay, so some directions on how you can find that 0. Let's do the whole thing over now with a quadratic. Okay, so taking a look at the quadratic equation right here. We're going to go back into y equals, clear this out. We have 2x squared minus 3x minus 2. Again, we're going to graph that. We want to take a look and see if this is a good size window. This is a window that I would adjust. Okay, I would adjust this window because the graph is very much to the center of our screen. It doesn't occupy a lot of our screen. Could you leave it like this? Yes. However, we're going to adjust it. We're going to bring it in. I'm going to let my x's run from -5 to +5. My y's, I'm going to let those run from -5, but I'm going to leave it running to 10. So I'm going to adjust my window so that the actual parabola occupies more space than it is right now. Okay, so what I did was I brought my x's in and I brought my y min up. So now when I graph it, I should have a better picture here. Okay, we want to find the zeros. Again, the zeros are where we cross the x-axis. So looking for those, we're going to go through the process that we did before. We're going to do second trace, and we want to find zeros. Now, my cursor is sitting here, and I need to be on the left side of one of my zeros. My 0 is right here. If I need to be on the left side of this, I need to be above it. I need to be over here, which puts my graph above. So I'm going to move my cursor to the left side and hit enter. Then I'm going to move to the right side and hit enter. I don't move real far away from it. I hit enter again, and what I find is that my x value is -0.5 when my y value is 0. I have another 0 I need to find over here, so I'm going to go right into second trace, calculate my 0. Then I need to get to the left side. The left side this time is down below. Okay, so I'm going to stop right about there. I hit enter, and then I move to the right side, hit enter, and I'm not going to guess, so I enter, and it says my 0 is at 2. So x equals 2 when y is 0. I need to draw a graph of what I have, and I need to mark what my window is. I'm going to draw the graph first. This time when I draw my graph, I stayed center up and down, but I did not stay center this way. I'm more down than I am up. It should be about a 2/3, 1/3. We know that our point out here is at -5, so 1, 2, 3, 4, and then the window actually ends at 5. 1, 2, 3, 4, and the window ends at 5. This 0 is at the point 1/2. This 0 is at the point 2. When we draw this then, we want to mimic what we see on the calculator going up on either end of our parabola. The last thing we need to do is write down what our window is, and you may remember what you set your window at, or you may want to just go back on the calculator and check. Our x's run from -5 to 5. Our y's run from -5 to 10. The last problem that we need to do is one with absolute values. Okay, taking a look at the intersection here. Okay, note we can either bring the 10 over, okay, since they asked for intersections, we're going to solve it using intersections, so we won't bring the 10 over. We're going to set up two individual equations. The first one is y equals the absolute value of 2x minus 1. The second equation is y equals 10. So we're going to look for a point on the graph where these two intersect. So when we go to y equals, clear out what you have. We need to do y equals the absolute value of 2x minus 1. The absolute value is found on the math key under number. So math over to number, and number 1 is absolute value. So you hit enter. We want to type in 2x minus 1. Close up that absolute value. On the next line in y equals, we want y equals 10. Okay, now we can hit graph, And there's our absolute value curve, the shape of a V. And then our value of 10 is way up at the top. You might have seen it run across way up at the top. We want to have a better picture than this. So what I'm going to do is I'm going to go back to the negative 10 and 10 for x. I'm going to leave this down here at negative 5 because I don't need this graph down here. But I am going to go higher up to 15. So adjusting the window, we want to go negative 10 on the x to positive 10. The negative 5 was okay, but let's go up to 15. Now hit graph again. Now you have a real clear picture of the absolute value graph and the horizontal line going across. Our intersection is here and here. So these are the 2 points that we want to find. So we're going to do things somewhat the same but a little bit differently. We're going to start with second trace, just like we did before. However, we don't want a 0 this time. We want number 5. We want the intersection. We're looking for where the 2 curves intersect. Okay? What your calculator does then is it is running, the cursor right now is running on the first curve, and it's saying, are you on your first curve? Well, we are, but we want to get close to our intersection. So we're going to use the arrow, the left arrow, to get closer to our intersection. You don't have to be right on top of it, you just need to be near it. And you can hit enter. Your cursor automatically jumps in this function right to the other curve. Hit enter again. This menu for guess comes up. We're ignoring that, bypassing it. And we find that our intersection is negative 4.5, 10. So when x is negative 4.5, y is equal to 10. Now we have another point of intersection over here on the curve. So we're going to do second trace, intersection, and this time we're going to use the right arrow key to get close to that point where the 2 curves cross. So as the cursor makes its way over there, I'm on my first curve, I simply hit enter. Then it jumps to the second curve, so I hit enter again. And then I want to bypass the guess, so I hit enter. This time I find that my x value is a positive 5.5 when my y value is 10. So solving graphically is easy enough to do here. The last piece that we need is what we set our window to. So if you didn't remember, you can go right back to window. Negative 10 to 10 for the x's and negative 5 to 15 for the y's. So as a review, in this case, when you're using intersections, you want to do second trace, but this time you don't want the 0, you want intersect, and then you're on your first curve, you're on your second curve, and then you hit enter to bypass the guess, and you hit enter again. It's pretty easy to solve these graphically.